Good morning, ladies and gentlemen. Today we are on to a planning domain. Plan well, execute well, use the services of what is executed. So the very the beginning, the very germination of the thought, sowing the idea, growing the idea, and using the idea, everything depends on that concept, a little planning. There are companies which spend years in planning and months in executing, which is a tall order. There are a few who plan fast but plan very, very deliberately. They use all their resources to plan well. Planning, therefore, is the most important aspect of a project. Monuments can become monumental blunders if planning is not done properly. Leaning Tower of Pisa is always leaning, though it's a unique attraction. Ladies and gentlemen, therefore, today's panel discussion is having a few of the subject experts who have been there in the organization of MES for a number of years. So now we have in the MES organization junior engineers who are the go-getters who get the work done. We have got assistant executive engineers, inter alia AGE, assistant garrison engineer, who are 100% responsible for the quality of the product and the project, but they work under the guidance of the garrison engineer. Now, a number of garrison engineers come under a commander works engineer. The planning takes place in a zone headed by a chief engineer like me. And we work through the commander works engineers, who has a number of garrison engineers and a number of assistant garrison engineers and a number of junior engineers. So in this discussion, we have picked up a beautiful project which has been planned pretty well, which has been planned with painstaking efforts, which has been planned over a period of months and using all the latest technology. It's a happy marriage of both human and technological intervention to come up with the correct expanse of the project. Spearheaded by the zone of Gandhinagar, of which I am the chief engineer, Brigadier G. Muthukumar, and my CWE in this project has been Commander Works Engineers sitting next to me. You may introduce yourself.
Good afternoon, ladies and gentlemen. I am having some experience in the MES and overall project executions and planning as well. Overall, my service is around 21-22 years.
Thank you. Ladies and gentlemen, so if I have, say, 32 years of experience or 33 years of experience with a PhD in infrastructure, which goes to look at my theoretical expanse, I rate the practical experience I have gained in organizations like BRO and the MES and combat engineering projects to be a telling, defining landmark influence on my whole life. So coming to this project which we are talking of is a greenfield project of an Air Force station at a place called Deesa. So now looking at this project, I would like to start off asking a few questions. Shri Rajiv Kumar. So what do you think was the importance of planning pertaining to this project?
Planning of every project is used for preparation of DPR. Basically, in any preparation of DPR, we need to collect the ground data first and then user requirement in planning stage.
Okay, so what you have secondly put across is that ground data is much important, and once accurate ground data is picked up, the user requirements are juxtaposed on the ground data, and that is how you come up with the DPR.
Correct.
Occasionally you call it as a DPR in some organizations, and in some organizations you simply call it as a project. So that's okay. So the homework is what you spoke about. Good. Now coming to the highlights of the present status of Deesa station. I would ask Mr. Lavakush, present status of Deesa station.
Palampur district, and Air Force Station Deesa is situated approximately 25 km from Deesa Taluka. Deesa station is surrounded with approximately 22 kilometers boundary walls, 20 numbers watchtowers and perimeter walls. There are only one OTM accommodation, one married accommodation and two JIS quarters. There are numbers of trees in the stations, and there have numbers of animals, nilgais, cows, camels and more animals live there.
I'll choose to just give an input, additional input on both the aspects. Firstly, the question regarding the planning which was concerned. Now, planning for any project is very important, because any mistake which is committed during the planning stage, any minor error, it can cause very much, the cost during the execution goes very much higher, and secondly the time penalty that is imposed is quite momentous as compared to the minor error that may have been executed during the planning stage. And in such kind of projects wherein Air Force operational requirements are there, we cannot afford to make any such minor errors also. So planning has to be very, very detailed, both in terms of saving the cost, economizing the complete effort, and also with the operational urgency in mind. Deesa station as such, if we see at present, it is nothing but a huge area of land which is forested, which has got boundary wall around it, and bare minimum presence of the service personnel to guard that location. And thus, to develop this complete greenfield area into an operational Air Force station with the runway as well as all the infrastructure that is required for functioning of Air Force requires a detailed planning.
That's very well brought out. I would like to ask Mr. Patwa, you are looking after electrical and mechanical aspects, which in the civil street is called as MEP. Now, in electrical mechanical aspects, what did you find to be the importance in the planning stage?
Firstly, basically E&M is a very important role in the every project, because what happened, suppose anything is required, or what is the capacity and what is the requirement of the users, we have to plan accordingly, and services are available or not. All aspects are covered in the planning stage.
What he is trying to say, if I understand, is that you have to see what is there,
Sir,
what is needed, and what is a gap,
sir, correct.
and what needs to be provided. So this is for electricity, internal, external, for water supply, internal, external, for sewage disposal, internal, external, and hence it has to be a comprehensive analysis of what you have and what you don't have and what is needed. Hope I am clear.
sir.
So now coming to the extensive means of data collection for such a electrical and mechanical planning, what was it in this Deesa project?
We have catered mainly electric supply load. So what is the requirement basically, and site requirement and users requirement. We have to cater these, and as well as mainly the water supply is available or not there. There is a borewell, groundwater services are not required. Rainfall is not sufficient there. So we have to cater for the borewell to achieve the project.
Okay. So, ladies and gentlemen, now quickly let us look at this Deesa project per se. So, it has been brought out that the electrical and mechanical aspects were looked into, what they have, what they don't have. So far as electrification was concerned, they had a 22 kVA line and they did not have anything other than that. So they catered for what all paraphernalia needs to be created from that downtake point, where to enhance, where to have distributions, and they also planned for in an immediate water supply in terms of a few bore wells, and they saw whatever little water supply connection was already available, and to enhance it as to what all water supply mains they have to have and what all storages they need to have. So these are all on the vague or the abstract end. Now it was to just start off to say that you start a planning process. But then, gentlemen, you come from macros to micros. If I take it as a micro, first you will have to look at the macro of the planning and then come down to the micro. So, CW sir, a lot of data would have needed to be collected for coming up with the planning of the Deesa station.
Correct.
So, what do you think was the expanse of data required and how did you go about collecting the same?
When the planning process of such a major project is being undertaken, the data is required to come from the various sources. First of all, the requirement of data which was supposed to come from the Air Force authorities themselves, that what kind of manpower or what kind of number of people who are going to stay there, in what capacity, that brings out the infrastructure that is required by them in terms of operational requirements, a runway, hangars, ATCs, the sheds for the aircraft, and all these structures which are required for the operational purpose. The administrative infrastructure in terms of offices, the various accommodation which are supposed to come up for the vehicles, for the various plants which are going to be involved there. Subsequently, for all these things, we require to have the dedicated services in terms of water supply, electric supply, sewage lines, and these things have to come up. Now, to talk about the infrastructure part per se, and once the strength has been given by the Air Force, there is a level of flexibility that is required to be built in into the complete system, because operationally the station is planned for a particular number of aircraft, a particular unit which is of operational nature, and there is an inherent flexibility in the operational plan as well. However, once we start the planning process, we have to start with a concrete number. So that has to be finalized vis-a-vis the cost effect. One can go ahead and plan for a very big infrastructure, but however, if it is not utilized in future to its complete potential, it may result into a loss to the government exchequer. So that strength, once it is finalized with the user, that becomes the prime input that is required. That is number one. Second is for the infrastructure development which is concerned, whether it is runway, whether it is buildings, whether it is roads, both external and internal, the various water supply sumps or sewage lines or electricity supply, all these things require a lot of data in terms of whether the infrastructure, the runway, it is sustainable in terms of the local conditions. Now, when I speak of local conditions, it means the local rainfall data, local flood conditions, local soil conditions, the water table, underground water table which is available, these kind of data are acquired. Now, if I go one by one, for this particular project per se, once the strength was achieved or once the strength was given to us and we started working on the major infrastructure that are supposed to come up in the first stage, first one was the runway. And for the runway design, we required certain aircraft data that came in from the Air Force authorities, and apart from that, for the designing purpose itself, we had to have a detailed soil investigation of that area. Now, once we talk of the data that is required for the soil investigation, generally everybody is aware of what is the soil bearing capacity is, but for such critical infrastructure development like runways and all, you require the additional properties of the soil to be investigated in detail, like K value, and for all these SBC, K values, and the number of chemical compositions of the constituent material of the soil, the number of tests very extensively has to be done. For the soil investigation itself, for the runway portion, we had gone about 256 borewells for the soil investigation only. And we have taken around 117 places where we tested for the K value. And these are elaborate tests. For generally on field, these kind of tests requires a huge amount of equipment and infrastructure. But we did not had the luxury of spending as much time as we wanted, so we had to improvise. We have to bring in additional equipment. So one of that equipment which we used for the mechanical means was the calyx equipment, and because of that our process hastened up. We could bring out the soil samples, transport it all the way from Deesa to Ahmedabad, which itself is around 4 hours drive and around 200 kilometers, and these were made to reach the accredited labs in the proper time frame, and the results were also acquired under proper supervision, approved by the government authorities in a proper time frame, and these were further supplied to the ENC branch, our higher headquarter, who were responsible for designing of the runway. Now this is as far as the runway is concerned. A massive exercise has been undertaken for the drainage planning of the station, which I'll like to describe now. Now this station is generally in the border of Gujarat and Rajasthan. The rainfall is not very heavy. However, water table is also pretty deep. But in 2015 and 2017, span of around 2 years, the complete area witnessed a very huge flood condition in the complete region of Gujarat, and we saw the effect of these flood conditions in this particular station, wherein there were major breaches onto the boundary wall. Portions of the land has got flown away, and while exiting the water from the station, it also broke portions of the road. It swept away the portion of the road, it swept away the portion of the boundary wall, and that was the quantum of water and the drainage that was there. So the major emphasis was that the runway, once it is designed, or the infrastructure when it is designed, it should be able to be self-sustainable, in terms of it should be able to withstand one of the worst of the rainfalls in the region. So for this purpose itself, now I'll get into the planning process of the drainage, which itself is a case study, and the Chief Engineer Air Force Gandhinagar, and in association with IIT Roorkee Hydrological Department, has actually undertaken this work which has been extensive, and it is a sort of a case study for the entire MES fraternity itself. So once we are carrying out such kind of effect of such kind of floods in the area, what all things we do generally cater for? One thing is the terrain, is the ground, the lay of the ground which is there. Second thing is the water which gets accumulated during the heavy rains or such kind of flood conditions. Third is what is the kind of surface which is around, how much water it is able to absorb, what is the runoff coefficient, and the water bodies, if we speak to, the water will always run off and find its way into the river. So which is the major river which is nearby, what is its cross section, how fast the water will reach here, all this process itself gets amalgamated, and then only you can come to a logical conclusion. And it was very much required, because if we are going to have a Air Force operational runway facility at that point, we cannot leave it to chance. It has to be properly designed with facts to back it down. Secondly, now how have we gone about it? The first survey that was undertaken, as you have already been told, that the station is forested. It is having a lot of forest cover in the initial part. So the first measure that was done was the survey was carried out by drone. The Army Unit 501 survey group came onto the site, carried out extensive drone survey, and with that the lay of the station was actually captured using the software, Bentley software called Capture, and from there the further activities were undertaken.
So, a very elaborate answer, because planning is elaborate. There is no secret about this. It can't be answered in 4 syllables. It has to flow from origin till end. It has to touch all the aspects. Now let us say that the military survey was approached, so they took a drone and they saw the whole area, mapped it, used Bentley software, they captured it. So the topographical survey was completed and the hard copy of the contour map was formed. Now hereafter, you would have detailed the soil survey team with some ideas as to what all needs to be done. So how many teams did you deploy? Did you have any JE to record the soil survey that is going on? Was it done by an external agency or an internal agency? In any case, you had already brought about calyx being used, plate load also you would have set there, and the K values, etc. were very important. It had to be shown to the user also, so that he is also part of the board. Could you throw a quick glimpse as to how you went about this?
The soil investigation which was to take place, as I have already brought out, the soil investigation was very important as far as the runway design and the other infrastructure design was concerned. So there was a proper outsourcing of this work was carried out, and it was given to one of the very reputed agencies who carries out professional soil investigation work. Notwithstanding, we had our dedicated garrison engineer, it was regularly visited by the assistant garrison engineer, and we had placed a team at Deesa itself comprising of 2 JEs who were there during that entire period along with this team to record every data, every occasion, every location that was being noticed. One was there were around 10 to 12 teams that was deployed, and if I again remind the viewers, this area was actually forested. So on a map it is very easy to make out right now that okay, this is the runway alignment and I have to make the boreholes at these places, but on ground once you go, the complete sense of orientation goes away. So first of all, we had to finalize the location from where to start to. Then what we use as something known as differential GPS to mark the prescribed location from the map onto the ground. And Once these locations were finalized, covering the entire length of the runway at an interval of 3 meters each team was deployed along with them. Each JE was monitoring around 3 to 4 teams. Despite the movement because of the undergrowth and forest was difficult, but the team went on each of the location and carried out diligently and deliberately the boreholes and the sample collection at each of the points. It was a very mammoth effort on part of the junior executive, and the Air Force authorities, right till the level of senior officers, administration at the command level, had personally come. They had seen the how the samples were taken, how it was being marked. The representative from the runway directorate of ENC branch made a personal visit to see how the K value are being tested, and he in fact there was it was recalculated. It was the demonstration was given at selected locations to see what is the exact value that is actually coming. So that is the kind of deliberation we have gone into.
Thanks. I must admit that the soil part has been gone into very deliberately. Occasionally, what will happen? They will say that so many holes were dug. Where is it recorded? Who was there? Was it shown to the PMG? Was some other echelon going and taking sample tests? All of that adds to gravitas. Things become more better. Now you would have made a DEM file and then you would have transferred it to a DWG file using QGES software. Now, thereafter, you would have gone for verification of the extracted data and the levels available. Thereafter, you would have gone for various departments to get data available so that you are able to juxtapose all of it. Like if you get an SRTM image, you digitize the SRTM image of the entire area. You already have the contour sets from the Bentley software of the drone survey. You are also having the DEM file, and now using QGES it will be a DWG file. So all data, when it is superimposed, you would have got a fully populated data sheet. But then which are all the government departments to which you had gone for understanding about the floods of 2015 and 17? Which were the dams that you looked at? Which were the rains that you looked at? Which were the government departments that you went to? Please.
So once the topographical data was collected and collated both inside the station and outside the station as such, from where the water was supposed to come, once both these things were done, the next important part was to calculate the quantum of water, the level of floods, and 2015 and 17 has been the worst recorded floods in the history of Gujarat. So this data was to be collected from authorized and reliable government sources. So we had personally approached the Hydrological Center of Gujarat, which is based in Gandhinagar. We had, for collecting the rainfall data of the past 50 years. Past 50 years the rainfall data was collected from here, plus the water levels. Secondly, we went to BISAC, that is Bhaskaracharya Institute, for collecting the exact satellite imagery of at the peak flood time, what was the water levels or the complete inundated areas in and around our station, to the vicinity of around 50 odd kilometers from the station itself. Apart from that, the data that was collected was of the two dams and the river that flows nearby. The major river which flows in the proximity of the station is River Banas. Now, this river is around 26 to 27 odd kilometers from the station itself, and there are two reservoirs, there are two dams. One dam is Shipu Dam, another is Dantiwada Dam. These are the two dams on the river in the close vicinity of the station. So, one of the major factor which the planning stage or the planning team was to consider was whether in the peak floods the water of these reservoirs will get flooded, over flooded, and these are the water which has been reserved in these reservoirs will come into the station and flood the station as such. So after the deliberation and the detailed calculation, which I'll come up subsequently how we had carried it out, one of the major conclusion of the entire team and what we wanted to rule out was the water from these two dams are not going to inundate the station as such. That is one. So for this purpose itself, how it is to be done, we had used software called HECRAS, that is river analysis software. It has been designed in Hydrological Engineering Center, which is based in California, US. And this software is an open source software. So there are two versions of it, HECRAS and HECGeoRAS. HECRAS is primarily used to carry out the two-dimensional analysis, and HECGeoRAS was further used to carry out the three-dimensional analysis based on the cross-section and the center line of the river itself. And this data, along with the complete the terrain of the station itself, the terrain of outside the station, and the rainfall data and the flood data, it gave us the correct conclusion that this water is not going to come inside the station.
So I understand that you had gone to Bhaskaracharya Institute of Space Applications and Geoinformatics. You had also gone to the Gujarat State Water Data Center for hydrological flood analysis. You had gone through flood inundation maps. You had taken data from all such sources and then extrapolated them. It's understood. Now you finally got the cross section of river Banas from the center line. So that means now you were at a situation when you could understand that river Banas, if it overflows or in its maximal flow, where all it can influence. And then you had two dams which you were touching upon, the Shipu Dam and the Dantewada Dam, and how much discharge they can provide. Now all that coupled with the catchment areas. Now when such geometric data, inflow and water level data is put through the digital elevation model, say using HECGeoRAS software of the riverine analysis systems which you spoke of, taking the catchment area, the roughness coefficient and the related data, you would have gone into the analysis. Now you would have extracted what water depth would have been there using HECRAS. You would have gone into 2D, you would have gone into 3D, you would have gone into HECRAS, you would have gone into HECGeoRAS. Once you had done all that, you would have used ArcGIS for inundation mapping. Till now, I am understanding it. So are we all. Now the point is, when the terrain mapping of the entire station is done through GIS, you would have seen that A is not affecting, B is affecting, C is affecting more. Or you would have seen that focus should be on this, focus should be on that, the macro movement should be from here to there. Such kind of larger deductions would have come out of this process. So, how did you choose a consultant for this job? How did you course guide the consultant in the interim? Was there a need to sit with a consultant? Was there a need to go to the university on which you were relying upon or some experts? So how did you course guide this analysis and how did you arrive at the larger deductions, the CW?
First of all, the question which has been asked, that how have we actually gone about the further planning process. The entire planning process of this water analysis or the flood analysis has actually resulted into the deduction of the major drainage of the station. Now, the major drainage of the station, why it is important, how it is important, that we have already seen. What is important to understand is that once we had taken out the Shipu Dam, Dantewada Dam, the outflow from there, and the overflowing of the river from the, in the worst case scenario, we came out with the catchment area, which is actually going to affect the station as such. This catchment area was roughly around 4,800 hectares, and the station itself is around 1,800 hectares. So you can see that this is the area which is the water from this particular area is going to come into the station as such. So what was critical to understand that once the initial DEM file was made, you get two things. One is what are the highest point in the station and what are the lowest point in the region. So if you join those higher points, it will give you a sort of a ridge line, and if you go for the lower points, it is generally give you the idea of the drainage pattern, the natural drainage pattern of the complete region. So it was from the northwest to southeast or northeast to southwest in this particular region, and our main endeavor was that the drainage should be planned taking the natural lay of the ground, the natural drainage pattern of the station should be utilized as much as possible. So what has actually happened was, once the outer catchment area and the inner catchment area was deciphered, that is in terms of that this is the catchment area from which the water is going to come to the station, we further went ahead subdividing the station into the smaller catchment zones based on this ridge lines and the drainage pattern which evolved from it. So we saw that which is the best course possible once the drainage is being planned, which requires the larger dimension drains, where you require the smaller dimension drains. And this process is a very deliberate and very complex process. It is the amalgamation of various techniques which are being used, and it's something which is on the very complex side or the higher side of the civil engineering. It's not normal concreting procedure as such. It is something very deliberate. So first of all, the consultancy whom the outsourcing was to be done to had to be given these conditions, these preconditions. They have to give us these outputs, and they should be able to meet our requirements. And secondly, for verification of these preconditions, verifications of this data, the output which the consultant is going to prepare, we required a sort of a help which was beyond the technical capabilities of the department as such. But being in India, we have no dearth of the technical expertise, and we contacted the best. We contacted IIT Roorkee, and I give you the name. Professor Z. Ahmed was the HOD of the department, and he was incorporated in the complete drainage plan, the flood model analysis and the drainage plan from the very beginning. So at each stage, once the data was prepared by the consultant, once the DEM was prepared, once the river analysis software outcome came up, once the minor catchment areas were drawn, once the rough layout of the drainage was planned, at each stage the consultant brought the data to us. It also brought the data, we also took it to the Air Force authorities for their vetting, and then we went to the IIT for their views and whether it can be further economized, whether it is safe, whether all sorts of contingencies have been catered into it. So that sort of deliberate actions were taken, and these deliberate actions we had to take in the sense that there were regular meetings comprising of the planning department of the Chief Engineer Zone, the executives, the consultant rep themselves, and the IIT professor, both at Gandhinagar and also at IIT Roorkee. Further, once the drainage plan was designed also, we had taken the entire team before it is being finalized to the site on numerous occasions so that they have an on-ground view of what is the profile, what is the ground profile is like, how the sections, if they are cut, what sort of the soil strata is there. So the complete thing, the drainage plan was monitored from day one at each and every stage.
So now I understand that you have come to an analysis based on a 50-year data. You have seen the worstest possible, what all can affect the station. Your alignment of the runway is as per the flow, as per the runoffs. The macro runoffs have been handled by correctly seeing the amount of water that will need to be discharged. Before this, the catchment areas were identified. It was seen as to what will contribute and what will not contribute, how much is the quantum, how it should be spread out and taken out, what will be the entry profile, what will be the exit profile. If that's the case, I would like to ask the Commander Works engineers that was this kind of a project possible to correctly reach a conclusive planning stage where domain experts from IIT Roorkee were called in, 50 years, 25 years and 10 years frequencies were worked out and options were generated so that as a developing country we do not over plan, neither do we under plan because it's an important asset. Intensity, duration, frequency curves were also plotted by you finally and made use of. Technologically, I feel that this was not an ordinary planning exercise. It was more of an in-depth planning exercise. So, once we complete this planning discussion, I would request you to show us the terrain mapping, the digitization of the SRTM image, the extraction of the river center line as to from what distances, what water depths we are obtaining, the DEM modeling. All such things can be shown by you so that we can understand the same. However, my compliments to you for having brought on this panel discussion the actual junior engineer, the AGE, the DCWE, the people who were genuinely involved. Rather than having a panel discussion with people who were not involved, I would rather always feel good about the panel discussion in which we have the real protagonists who were involved. My compliments to each one of you. Thank you for joining us. Before we sum up, you could like to flow the slides. And in summing up, all that I would like you to show is as to how you went in for the cross-sectional details, because that will not have any technological relevance that will have technological relevance but not any security relevance. So I would like you to show as to what kind of drains, what kind of roads, what kind of cross sections you arrived at. So that can also be shown and that will be a visual summing up of the result of the planning exercise. Many thanks.